Please be seated. Please be seated.
I hereby open the meeting. Mrs. Ochoa Rosales, I bid you welcome. You are appearing before the committee appointed by the Doctorate Board of the Erasmus University Rotterdam to defend your thesis and the appended propositions. But before we start the discussion, I invite you to give a short introduction in which you tell us about the subject and the aims of your studies and your findings. The floor is yours.
Dear Mr. Rector Magnificus, committee members, colleagues, and friends. In the next 15 minutes, I will present you a summary of my PhD research focused on determinants of type 2 diabetes and underlying mechanisms. Type 2 diabetes is a metabolic disease characterized by insulin resistance and high glucose levels in blood. The number of people with type 2 diabetes around the world has been increasing in the last decades, becoming a major public health concern in most countries. Type 2 diabetes is the result of a complex interplay between environmental and genetic factors. Lifestyle factors such as our diet, medicines we can take, and smoking can affect the expression of our genes, and this could happen differently between men and women. But how could this happen? Epigenetic mechanisms have been proposed in the last years as a link between environmental and genetic factors. What is epigenetics then? Epigenetics is the study of changes in the function of our genes that do not comprise changes in the DNA sequence, but attachment of some chemical groups to it. Two of the most studied epigenetic changes are DNA methylation and histone modifications, as you can see labeled in the figure. DNA methylation refers to the binding of a methyl group at certain sites of the DNA, while histone modifications refer to the binding of some chemical groups to the histones, which are the proteins to where the DNA is wrapped around. These epigenetic changes are a mechanism to turn our genes on and off, therefore changing our gene expression and phenotype. These changes occur naturally in our cells, and actually they are needed for correct development. These epigenetic marks can be inherited from our parents, but they can also be modified. These epigenetic marks are sensitive to suffer modifications as a product of the exposures we have during our life course. Then environmental factors, how I mentioned before, can have effects in our phenotype, and this could be mediated by epigenetic changes. That is why identical twins with the same genes can have different health outcomes, one being healthier while the other can present disease at an early age. There are also other mechanisms that can exert the environmental factors we are exposed to, such as inflammation changes or changes in our inflammatory response. These lifestyle factors can have anti-inflammatory or pro-inflammatory proteins that can be protective or can be can constitute disease risk, for example, to type 2 diabetes. This disease is partially considered an inflammatory disease. Therefore, these factors may affect the onset of type 2 diabetes. Therefore, the aim of my thesis was to investigate environmental determinants, specifically medicine intake and coffee consumption, and its link to development of type 2 diabetes, potentially mediated by epigenetic changes and changes in our metabolism. And also, I was interested to investigate whether these changes occur differently between men and women. For this purpose, I performed two approaches. One was literature reviews to summarize the available evidence in the topic of type 2 diabetes, epigenetics, and sex differences. And the second was the performance of original studies, specifically observational studies embedded in prospective population cohorts. I worked mainly with the Rotterdam study and the UK Biobank, but I also had collaborations with cohorts from several other countries. In the prospective cohort design, we select a number of participants and we follow them up on time until the occurrence of the event of interest, which could be disease onset or death. For my research, I focused on middle-aged adults and in the elderly. In our literature review, I studied associations between DNA methylation and histone modifications and type 2 diabetes and glycemic traits. I found such markers in the literature, and I found that some of them, specifically regarding DNA methylation, were proposed as biomarkers for prediction, early diagnosis, and prognosis of type 2 diabetes. Next, I found that some DNA methylation markers and histone modifications were linked to complications of type 2 diabetes, such as vascular damage in the retina, kidneys, also damage in the peripheral nerves, and cardiovascular disease. Therefore, some of these markers could be targeted for potential therapies in order to prevent the onset and complication of this disease. Unfortunately, limited evidence we found about histone modifications as a potential biomarker. And finally, some inconsistency across the studies in terms of designs, assessment methods, and statistical analysis we found in this regard. Next, in our literature review, I investigated DNA methylation marks and in association with blood lipids, blood pressure, type 2 diabetes, and cardiovascular disease. And further, I found that some of these epigenetic marks were different between men and women. Therefore, we have to consider that if you want to use them as biomarkers, they will perform differently between the two sexes. And finally, further investigation is needed in terms of replication of studies and also increasing sample sizes. Next, in one original study, I wanted to address the link between statin use and type 2 diabetes risk. Statin is a medication that is prescribed to reduce the cholesterol levels in blood. And we found that statin users showed a higher levels of insulin in blood and HOMA-IR index. This is a marker for insulin resistance. And also statin users showed a higher risk of type 2 diabetes development. Next, we investigated whether DNA methylation changes could be mediating this link. And we found that statin users had higher levels of methylation at the gene ABCG1, which is an important gene for cholesterol transport and insulin secretion. So we further found that of the total effect of statin use on type 2 diabetes risk and insulin resistance. A part of that effect was mediated by methylation changes in that gene. And then we further hypothesized that changes in the expression of that gene could be explaining this observation. In another original study, I wanted to study the link between coffee consumption and type 2 diabetes risk. And I found that higher coffee consumption was linked to lower insulin resistance on time, as well as lower risk of type 2 diabetes. Then we further explored whether inflammatory response had a role in this, and we found that higher levels of coffee consumption were associated with a beneficial profile of the inflammatory biomarkers, and that part of the effects of coffee on lower type 2 diabetes could be mediated by changes in the inflammatory response. Then we studied uric acid and premature mortality in cardiovascular disease. And also we studied here whether type 2 diabetes status and sex could have a role modifying this association potentially. And we observed that in our overall population, the higher, serum uric acid is a molecule that it's normally in our body, and it's a product of our metabolism, and it can also change regarding to our diet, kidney function, among other factors. So I was saying that among the overall population, we found that higher serum uric acid levels were associated with a higher risk of mortality in cardiovascular disease. Next, we wanted to assess differences between men and women, and we found that for both of them, the risk of mortality and cardiovascular disease was increased, but in women, the risk tended to be higher than in men. We did a similar analysis comparing diabetic and non-diabetic participants, and we found similarly that diabetic participants had a higher risk. Finally, we wanted to compare 4 groups. So we selected diabetic women, diabetic men, healthy women, and healthy men. And we compared those 4 groups. And we found that among those, diabetic women tended to have the highest risk of premature mortality for all-cause and cardiovascular mortality. So in my thesis, I found that coffee consumption and statin use were determinants for type 2 diabetes, one being a protective factor, while the second being a risk factor. And this could be due to changes in inflammatory response and in DNA methylation of key genes. We also found that for DNA methylation changes, this could be sex-specific. And we further found that in the uric acid study, that higher levels of uric acid were associated with mortality and cardiovascular outcomes. And here we found that type 2 diabetes status and sex could play a role in changing the magnitude of this association among participants. Therefore, we concluded that epigenetic signatures can be used as a novel biomarker for early detection and progression of type 2 diabetes. We also concluded that the epigenetic changes can occur sex-specifically. We found also that changes in our epigenome could mediate the diabetogenic effect observed for statins. We also concluded that coffee's anti-inflammatory properties can explain part of the beneficial association of coffee consumption and lower type 2 diabetes risk. And we found also that type 2 diabetes and sex should be 2 factors to take into account to treat high levels of uric acid and to prevent premature mortality. So I finally concluded that by joining efforts to disentangle the underlying mechanisms linking determinants of type 2 diabetes, we can do some things, like we can identify novel biomarkers for new preventing treatments and monitoring strategies. We can understand disease etiology. And with all of this together, we can improve quality of life of persons at high risk or newly diagnosed with type 2 diabetes. And finally, some regards for the future, some thoughts for the future. I think we should focus on more replication studies of the recent studies on epigenetics, and this should be based on collaborative work. We also think that studies should focus in assessing longitudinal trajectories of epigenetic changes in order to capture the dynamic nature of epigenetic marks. Also, that the new technologies focused on measuring epigenetic changes should take into account comparability with previous studies to gather all the evidence. And finally, that sex differences should be more important to be addressed in future studies. This was my presentation. Thanks for your attention, and I give the word back to Mr. Rector Magnificus.
Thank you very much for your presentation. Mrs. Candidate, it's now time to defend your thesis, and I call upon now your promoter, Professor Ikram, to start the discussion.
Thank you very much, Mr. Rector. Dear candidate, I'm very excited to be sitting here today in front of you. In fact, very excited that we can be sitting here physically next to each other. I'm not sure how long this will last, but at least for your defense, that is the case. It's been a pleasure for me in the last 2 years to work with you, and obviously we have discussed a lot of these findings already. And as is the case with science, one answer yields many more additional questions, which I also will have. At the same time, we have a committee of distinct researchers that are willing to discuss with you on the thesis. So I first would like to give them the floor, and if there is time left, I definitely will come back in a second round. But for now, I give the word back to Director Magnificus.
Thank you. Now we go online, and I give the floor now to Professor Schneider, Professor of Genetic Epidemiology at the University of Groningen. Professor Schneider.
Thank you very much, dear candidate. I would like to congratulate you and your team of promoters and co-promoters with a very nice thesis. I like to focus on type 2 diabetes. At the same time, I was impressed by the scope of work and the sophistication of your study designs. First, I'd like to discuss your first proposition with you. And maybe one of your paronyms would be so kind to read it out loud for us.
Epigenetic signatures could serve as biomarkers for early diagnosis or disease progression in type 2 diabetes and as novel targets for the design of new therapies.
Thank you very much. So my question concerns that you seem very optimistic on the clinical usefulness of epigenetic signatures. And this reminds me a little bit of the early GWAS days when there was a lot of hype and GWAS was going to solve almost everything. And therefore, I would like to know from you, can you explain to me why you are so optimistic, and is this really justified?
Highly learned opponents. Yes, I personally love the topic of epigenetics. Maybe that also influenced me to be very optimistic. But we can see, for example, so in my own research, in both original studies and the reviews, I could see that there were some markers repeatedly. Several other studies found, let's say, some hits in association with type 2 diabetes in different settings. both in population studies, among general population, among diabetes participants, also some experimental studies with cells also found similar or the same hits in association with type 2 diabetes and insulin resistance. However, there's still a long way to go, as you address, for the use in clinical practice. But I want to bring the example in cancer, for example, where the epigenetic marks are better investigated. So, for example, in cancer, the epigenetic changes in some cancers are very well identified. And there are some drugs, some chemotherapies addressed to, for example, targets enzymes that methylate DNA, but also there's alkylating chemotherapies, drugs, that can be, in that setting, DNA methylation is used to see how the response to a treatment could be. Depending on the methylation of one of the genes, they could use it to predict if the patient is going to do good with the medication or not. So even though in type 2 diabetes...
If I may interrupt you, because cancer is obviously a very different type of disease compared to type 2 diabetes. So do you really think that epigenetic information will be able to guide therapy for type 2 diabetes? How would that actually work, you think?
Yes. For example, in our starting paper, we saw that the methylation at the gene ABCG1, two CpGs, and in particular one, was associated with, in our case, statin therapy, and with glycemic traits, insulin resistance, and insulin. We saw that in our study, also other population studies, and I was mentioning also experimental studies has found that CpG. So how I see it is that we will not maybe target that one CpG in a clinical setting, but maybe that it could be used as a measure maybe to follow up patients. So maybe patients at high risk, but who are not diabetics yet, who have not been diagnosed yet. Maybe you can use that CpG in personalized medicine, and not only one CpG, of course, maybe a set of them. We can use them for monitoring of patients before complications happen.
So that sort of relates to the next question I had in mind, because at the bottom of page 230 in your general discussion, you acknowledge that still more robust and replicable results from carefully designed studies would be needed. So I wondered what kind of studies you were thinking about, for example, for early detection, like you just mentioned, early detection of patients even before they develop the clinical symptoms. So what type of studies would you design if you would have sufficient funding?
Yes, funding is always the issue, but of course, a clinical trial would be the best design to think about for answering this question. And I would include repeated measurements of DNA methylation. That's something that there are no much studies that can address that. So I think that by monitoring changes, for example, in a group of participants, some of them with insulin resistance, then some of them will have diabetes, maybe some of them will not have diabetes later. And by monitoring epigenetic changes on them, we could address that.
But if I may ask, so how, it's well known that about half of the type 2 diabetes patients are unaware of their disease. So how would you go about detecting them in the general population? And how would you study whether that actually works for epigenetics? I don't think that a clinical trial would then be very suitable.
Well, in that case, the clinical trial would be, yes, not to be applicable in the real life setting, but it could serve to see, a clinical trial would serve to see whether these changes are, let's say, they truly come from that insulin resistance and type 2 diabetes development later. But for detection in a real life setting, other, as you say, other strategies should be, should be implemented.
And I'm not sure if I still have time for one short question.
No, I'm sorry. If you have no question, then I have to continue. Thank you very much for your questions. I give the floor now to Professor Gelijnse, Professor of Nutrition and Cardiovascular Disease at Wageningen University Research. Professor Gelijnse.
Yes, good afternoon, respected candidates. We are on the distance. You are even far away from home. Well, congratulations on this big day and the major achievements for you and your team. So I read your thesis with great interest, and I'm from the field of nutrition. So maybe you're not surprised that especially chapter 4 was something that I really was interested in. It's about the coffee. And I found out that Chile is the country where probably they have the highest incidence of diabetes in the world. At least I read it in some papers. Is that correct? Could you verify my statement?
Around 70% maybe of the population have at least the risk factor of being obese or overweight. So I'm not surprised if you mentioned that Chile has one of the highest rates of type 2 diabetes prevalence. It's a population at high risk, so I would agree.
Yeah, I found a figure of 12% for prevalent diabetes, and I think in the Netherlands it's around 10, or in the USA, so it's quite a lot. Maybe not the biggest, but and overweight and obesity seem to be a real problem in your country. So that's interesting, because coffee, as you state in your thesis, might prevent diabetes. So then I had an even more careful look into your tables. So maybe we could, well, maybe first go to your scheme in figure 2 in chapter 4. There you have a nice graph of how you could study intermediary factors. And what surprised me a little bit is that you have data at hand on body weight and BMI, but they are not in your pathways, not specifically. You choose biomarkers, CRP, adiponectin. What was the reason for not including BMI or body weight in that figure?
Highly learned opponent. Yes, indeed, in the figure, you can see the specific potential mediator factors that we chose for the design of this study. We didn't particularly include other biomarkers, but we were interested in the inflammation pathway, because coffee is one of the beverages that has the highest anti-inflammatory effects. And since it's also one of the most common drinks preferred by people, we were interested in the anti-inflammatory effects, particularly from coffee. However, you are also, I agree with you that those are also markers that we could have studied more in more depth. However, we addressed that by including them in the models.
Yes, maybe we could go to your table 2, where you present your main results for diabetes. And in that table, you made 2 models. And in the second model, you choose to adjust for BMI and lipids and blood pressure. And why did you choose to include BMI in that second model? Is that because you did feel it should be kind of intermediary factor and that you didn't want it to mix up with other risk factors? Was that the main reason?
We wanted to see whether it was in the... Sorry?
So you did a kind of intermediary factor analysis also there by choosing 2 different models.
Yes, indeed. So we wanted to see also whether it was independent from those factors.
Why do you think that for HOMA that the results really became a lot stronger after including these 3 variables in the Rotterdam study, but also a little bit in the UK Biobank? Which of these factors is the reason the beta goes down?
Yes, actually by adjusting for those factors, as you say, the effect sizes changed. So I guess that by taking into account those factors, we were addressing, let's say, better the model. And also we found some interactions with those. When we stratified, for example, for BMI, we could see different effects or stronger effect among overweight and obese participants. So I think that the interaction has something to do there.
I thought it had to do maybe more with the LDL cholesterol, because you don't split dietapines like cafestol because of not using a paper filter. Are you aware of that? And do you know that that espresso may increase your LDL?
I'm sorry, I lost you for a second, but if I understood your question well, you are asking me for lipids, effect of coffee on lipids? Yes?
Yes, yes. I saw a recent paper of UK Biobank where they did split up types of coffee, and they showed clearly that in those who drank espresso, the LDL was twice as high compared to the non-LDL, at least a change per unit. So, and I wondered, you had these data in UK Biobank, why you did not split up for paper filtered coffee versus other types of coffee.
On the supplementary data of that coffee paper, we have an analysis for a filtered coffee or ground coffee and decaffeinated coffee and instant coffee. We have those 3 separately. As you mentioned, is a UK Biobank data, so we have the results there. And we found that for ground and for filtered coffee, which includes also espresso in their FFQ, their questionnaire, we found that among consumers of filtered coffee, they had the lowest risk of type 2 diabetes. So overall, we found that coffee was associated per 1 cup increase around 4 to 6% lower type 2 diabetes risk. And among drinkers of filtered coffee, the risk of type 2 diabetes was lower by 22%. So indeed, I think that that might be because of the lipids effect, as you mentioned.
So that's really interesting. Eh?
Yes, indeed.
Okay.
Thank you. My time is up. Yes.
Yes.
Thank you.
Thank you. Thank you, Professor Gelijnsen. And from Wageningen, we go now to Glasgow, I give the floor to Dr. Celis Morales, Research Fellow at the Institute of Cardiovascular and Medical Science at the University of Glasgow. Dr. Celis.
Thank you. Good afternoon, everyone. Carolina, first of all, an excellent work. It was really interesting to read. I think that the connection within the chapters goes nicely. Some of the published work you have already are quite interesting findings. I really find striking these findings on coffee intake too. So as I have a few minutes to ask you a few questions, I want to start with your chapter 3 that investigated the associations between statin therapy and risk of type 2 diabetes. So something that I was concerned about is when you use a statin, you say that this was obtained from routine dispensing data. Is that right?
Very learned to opponents. Yes, so the Rotterdam study, yes, the Rotterdam study in this cohort, they got the statin use data from the pharmacies where the patients or participants obtain their prescriptions.
Did you find an issue then identifying who is actually not taking a statin compared to those that have missing data from a study?
That's, well, a good point and something I didn't address in my study, but I think that limitation could be in any of the population studies that the participants or patients may go to get are prescribed medicines, but at the end they do not take them. There are a few studies for that actually, and of course you find that some people do not take it, but we as researchers, we cannot know that. I think only probably a general practitioner can get their, for example, their lipids profile, and maybe the GP can think, okay, these people has been on statins for, let's say, 2 months, and I don't see changes in the lipid profile. Maybe that would be a practical way to find it out, but us as a researchers, at least in my studies, we did not address that.
Excellent. So I think that is pretty true, actually. It's hard to know how accurate they are in taking the prescriptions and so on. So you also said that risk of diabetes was higher on people taking statins if they were overweight or obese. So how much of this association do you think then could be explained by excess adiposity, but at the same time by the existing other comorbidities like hypertension or other diseases?
I think that what I've seen and some other studies have seen is that, as I mentioned in my thesis, statin use is associated with an increased risk of type 2 diabetes. But we see that participants that already had risk factors, let's say, higher BMI, of course, insulin resistance before taking statins, those are patients that have higher risk of type 2 diabetes when they start on statins. So our study, we excluded participants in chapter 3.1, that paper, we excluded participants using statins at baseline, and we follow participants who were like new users of statins. So for patients that already had risk factors, maybe somehow statins can accelerate the type 2 diabetes development. We didn't go into molecular mechanisms more precisely, but I guess that could be some explanation.
Yes, excellent answer. I think they could either maybe, as you say, accentuate the risk, but also masking maybe underlying risk factors. So people with statin may have another factors that influence the high risk of diabetes.
If
so
I can
in terms of coffee, I find it really interesting. And I always read these papers on coffee saying, don't drink coffee, or just stay out of coffee. So how do you think that your findings translate into other countries? Because one of the things is socioeconomic status. So is everyone drinking coffee from affluence or high income sectors of the population? Is that true in developing countries or third world countries, for example, third income countries? So how do you translate that to other populations outside of Europe?
Of course, my study is not generalizable to all population because we didn't address, for example, ethnical differences. For example, that's one thing that we didn't do, so our study would be limited. And also, although we, in our statistical models, we address socioeconomical status by the deprivation and index in the UK Biobank and education level in the Rotterdam study, I think that maybe it could change per country and per socioeconomical status condition would be the type of coffee that people may drink. For example, in my country, they often drink instant coffee, which is maybe not the best quality, but now people are buying more espresso machines, and they are moving forward maybe grained coffee. So I think it depends on and as we saw in our own study, the magnitude to what extent type 2 diabetes risk was lowered also depended on the type of coffee. We also know that in some other countries drink the ground coffee just directly in the cup, so they don't filter it, so the coffee powder, let's say, it's there in your cup. So it's not only about drinking coffee, but how, what kind, and at what time also.
So there are several factors that could influence themselves. That is excellent. Carolina, final question, really short, and this is kind of a reflection. I have the option of awarding you £1 million to follow one of these questions to the next stage. Which one do you think that you will go for? So you have really interesting studies here, but which one is worth it to pursue a further investigation?
Do you mean among all my studies?
Yes.
Oh, that's a difficult question.
Yeah, you need to make a decision based on what you think will have a high clinical relevance, but also is relevant for you.
So if I had unlimited funding, I would go for a longitudinal study on epigenetics. I think that's a very promising field that needs more research. So maybe other studies will make more studies, for example, on coffee consumption, but maybe the research on the epigenetics field is more scarce. So I would prefer myself to follow the epigenetics on type 2 diabetes.
Excellent, Carolina. So as I said before, excellent work. I really enjoyed to read it. I think it's a high quality work, robust analysis. You highlight limitations and strengths in your studies, which is really good. So congratulations on that.
Thank you.
I don't have any further questions.
Thank you. We go back now to the hall, and I give the floor to Professor Strikker, Professor of Pharmacoepidemiology at our university. Professor Strikker.
Thank you very much, Mr. Rector. Dear candidate, my congratulations with this really excellent thesis. I always learn a lot from all these theses because I was not so very much acquainted with epigenetics. I still am not, I'm afraid, but it's quite complex. But of course, I had some experience working together with you and Dr. Muka on the statins. And I also, I was quite happy to see that you took into account also the dosage. But I was a bit surprised that in the future research, I miss I miss a part on what you could do with this in the field of pharmacogenetics, and also, for instance, with the statin research itself. Because you saw an association between especially ABCG1 and the effect of statins on glucose. But then, of course, diabetes mellitus is a disease where the duration of the diabetes is very important. So I could have imagined that in your future perspectives, you would take a step into the direction of seeing what the duration of diabetes would do on the endpoint, and whether maybe statins, it's better to stop statins in people with this marker whatsoever, and give them, for instance, clofibrate or something else. So what is your, what's your reaction to that?
Highly learned opponent. I agree. I have to agree that I did not make that point in my in my future considerations. That's, yeah, points I might have missed. I think that for the future, indeed, I think time-wise and dosage-wise, we have seen that that has an impact on the outcome. In the first paper, as of course you know, we saw that duration of treatment with statins had a difference. For the short term, we didn't see associations, say less than 30 days of use of statins. And then we did another subgroup of 30 days and less than 1 year, and then more than 1 year. And we, in the latter two groups, we saw the association. So for this, I think, as I also mentioned before, I would, for the future, recommend to do studies with a longitudinal approach and repeated measurements. Clinical trials...
Maybe you can be critical about this. You might say, well, I don't think this is really needed, for instance, because ... You can fill it in. Why?
I thought to consider that is needed. So,
but I would question that myself. I raised the question, but then thinking it over, I might say, well, if we see that it has influence on glucose, we simply titrate by reference to the glucose. And then if the glucose level remains, okay with a bit more insulin, then the duration of the diabetes will not have worse consequences. So I raised the question, but of course, it's not sure that whether that really makes a difference. Did you, by the way, look at, because sex is also apparently determinant of methylation. Did you stratify by sex on this association with dosage? Because you found an association with dosage, the E table 11.
Yes. You mean sorry, you just mentioned the table?
Yeah, here it says that there is a relationship between the certain epigenetic trait that you found, which is associated with statins, and with the dosage of statins.
Yes, no, in that case, we didn't look into sex differences, but it's something
because
that...
sex is also a determinant. Your 50% of your thesis is about sex differences in cardio and metabolic trait epigenetically, but you didn't study it here on the effect of statins?
No, in that paper, we did not do that.
Okay, this is also maybe some future research.
Yeah, do.
Now, okay, but now another thing. You can do much more with with drugs than simply what you do is looking at one time point and look at the dosage, because of course these people are titrated over time. Maybe they are down titrated, and maybe they're up titrated, and that might be related to this epigenetic trait. Isn't that something you might want to study in future research?
I totally agree that if we saw an association with dosage, we should look that further, because patients can change their dosage according to the outcome that they are showing. So they could be lower, they could have lower or higher dosage on time. For this study...
Isn't that, because the nice thing of having several endpoints is that you increase power. So you can find more epigenetic traits if you have so many endpoints.
We were in that particular study, we were very limited with the data available. We had the approach of asking other cohorts to replicate our study. And those other cohorts didn't have, for example, even data on former studying users. So they had much more limited data on the other cohorts. And of course, we need power to find associations. They also...
If you have one cohort, you can use all the prescription as an endpoint. So you have huge numbers of endpoints in a way. Now, suppose that we would do that, we're going to do that in the future. Do you expect an association between the epigenetic trait and these more or less change in dosage over time? Or would you say, well, I'm not sure whether I find something?
From our baseline findings, I think we could expect some change, and yeah, we already...
With which type of drugs would you more easily find something? So how do we prescribe statins? When we started with statins 20 years ago, we checked the cholesterol level, and so we titrated the drug by reference to the cholesterol level, but we're no longer doing that. Nowadays, we simply give a statin, the cheapest one, and we give one dosage, usually 40 milligram, I think, and that's it. So we don't check anything. We give it to everybody with diabetes, and that's it. Now, but another drug, like for instance beta blockers, is titrated, and you stop the beta blocker, or you lower the dosage if the people develop bradycardia. Now, isn't that a nicer endpoint then, maybe? Because we know, for instance, for the beta blockers also, that there are several, I think, there are also studies showing that there is association with epigenetic trait in the field of the beta adrenoceptors. So, and then you can titrate, you can make use of the complete data set of all these prescriptions, lowering dosage, or people stopping because of adverse reaction, and you get much more out of your data. You can find also more epigenetic traits and replicate them elsewhere. Well, I'm talking too much now. I'm afraid I have to stop. But just say that you agree with me, and thank you very much.
Thank you. We go online again to Switzerland, to Dr. Muka. Dr. Muka is medical doctorate, epidemiologist at the Institute of Social and Preventive Medicine at the University of Bern. Professor Muka, Dr. Muka.
Thank you, Rector Magnificus. Carolina, first I would like to congratulate on this PhD. It's great to see you maturing with this such a great book, and I was very happy to receive it and read with pleasure. Actually, we have discussed several of these projects before, so I would not like to go in details and statistics, but rather go deep on your optimism and see how we can try to test your optimism in the future, whether it's true or not. So if one of the paranames can help me with the proposition number 9, reading proposition number 9.
The observed health benefits of coffee consumption suggest that coffee should be a preferred beverage to take us throughout the day and to keep us healthy throughout life.
Was it 9?
There is a misunderstanding. Number 9, yes.
Science and everyday life should not be separated. Rosalind Franklin, chemist who provided evidence for the molecular structure of the DNA.
Carolina, this is a very provoking quote, and could you please elaborate a little bit further on this, and how does this apply to your own research?
Very learned opponent. Actually, what motivated me to use this quote for my thesis, I thought it was a strong message in terms on how science is seen from the outside science world, let's say. I was motivated because I see that a lot of people outside scientific field, they may not see the value of investing in science. Why would we spend our money in science, like our taxes money in science, when we can maybe give more subsidies, build maybe hospitals? And therefore, they are yeah, maybe less believers in the scientific importance and content. That was really my motivation. And of course, I think that scientific communication towards those people is very important.
Well, the idea is that according to research, only 10% access to care contributes only 10% to the life expectancy. So definitely lifestyle is an important factor. And when it comes to the epigenetics, and especially with statins, I mean, there is lots of doubts, and as you could see also from the discussion here, whether there has any clinical impact or either for prevention, diagnosis, or prognosis. So how would you, considering you do a clinical trial, how would you take this finding that you have for with regard to methylation and statin in relation to either prevention, prognosis, or diagnosis? So would this clinical trial look like?
First, I think we need to reassure, let's say, or replicate the current findings before even moving forward. Because from our reviews, we found that although there were some signs that were, a few of them, which were repeatedly replicated, the evidence is not still strong enough. So we should focus in replicating findings.
If I can interrupt you, I mean, in your case, it was also replicated by another study. So you have double replication for the findings, so, which is great news. And that's what you have to be congratulated. So what would be your next move when it comes, I mean, clinical trials are the gold standard. And you say that could have either diagnostic, prognostic, or prevention implications. So how would you test this in a clinical trial? Everybody wants to hear clinical trials results to communicate also better the results and findings.
Yes, so we should start with participants, for example, that have risks for developing type 2 diabetes. We follow them up with repeated measurements. I think that's a key, repeated measurements of DNA methylation. As I mentioned before, some of them will develop type 2 diabetes, some of them not. Some of them will develop the complications of type 2 diabetes. And we should be able to see a change over time in these epigenetic factors. So first, we have to identify them. And then we can set further strategies to include this in a clinical setting. For example, I think this should be implemented further in personalized medicine. So according to DNA methylation changes of each individual, we can apply the next strategy, how to treat that patient, how to monitor them.
Awesome. Well, if I focus on the personalized medicine, the idea is that, do you think that stratifying, assume that the patient is eligible to take statins, but as your results show, we can be aware that could be a risk of them developing type 2 diabetes. Would you measure this epigenetic mark like at ABCG1 to stratify patients whether, for instance, if they have higher methylation, maybe they should not take statin, but another medication. And if lower methylation, then they don't need to take, they can take statins because they probably are at low risk. Do you think this could be an approach and to be tested on future studies?
No, I disagree on that. I think more than changing the prescription or not giving them statins, we could use this biomarker to address the risk of that person to develop future type 2 diabetes. And maybe we use the methylation level of that participant plus other biomarkers, and maybe we should take measures to monitor that person more frequently. We should put an eye maybe on recommend that person to change for a healthier diet, to do physical activity. So we have an overall approach to prevent that person from complications. And then the methylation would complement, let's say, the current strategies. That would be one element additional.
Yeah, I also agree. And then I would add, I mean, among these prevention strategies, definitely lifestyle plays an important role. Why don't you look at dietary factors that could decrease the methylation levels of ABCG1? And maybe that could be, if you identify that, you could recommend patients taking statins, also using more of these types of food that you could identify decreasing the methylation levels.
I'm sorry, do you mean
one approach?
Why didn't I study DNA methylation in association with?
So I mean, in Rotterdam study, you have data on diet, several dietary factors. Could diet be a factor that could, for instance, there could be dietary factors that could lower the methylation levels of ABCG1, and this could help you to prevent development of diabetes in statin taker, in case this is causal effect, of course. Do you think this could be an approach and maybe something to consider in the future?
I think that could be my next project. So I think that's a very important, we should totally look into that. This, for example, this gene also has association with lipid levels. We know that diet influences stronger the lipid levels in our blood. So that's totally an approach how we can expand our research on these epigenetic marks.
I'm not sure if I have more time for a question.
No, because I'd like to give the floor to the co-promoter, Dr. Voortman, Principal Investigator of Nutrition and Lifestyle Epidemiology at our university, for the last minutes.
Thank you. So, dear candidate, well, of course, we discussed your past work extensively already. So in the last few minutes, and I'd like to look with you to the future. And you work with many cohort studies, right, in your thesis, Rotterdam study, but also many other studies worldwide, but mostly in the US and in Europe. And I know that you have the ambition to set up a new cohort study in Chile. What have you learned? What will you do in the design of this new cohort? And do you expect many differences? Well,
Mrs. Candidate, the time allowed for the defense of your thesis is over. The committee will now withdraw to deliberate, and would you please wait here until we return? I adjourn the meeting now.
Yes, I am. Yes, I am. You have a reception? Yes, upstairs in the foyer. Yeah. They know that? No, we haven't told. You mean the audience? Well, they should know, right? We can announce here that. Yeah. So right after the end of the ceremony, we have prepared reception. So you can exit that door, and you will meet me there.
be seated.
I reopen the meeting. Mrs. Candidate, the doctorate board of the Erasmus University Rotterdam, represented by me, has considered your thesis. And having heard your defense and the advice of this committee, I grant you the title of doctor. And I authorize Professor Ikram to bestow this degree upon you in the customary manner.
It is with great pleasure that I undertake the task the Rector Magnificus has allotted me. By the authority invested by law, and according to the decision of the doctorate board of this university, I hereby confer upon you, Carolina Patricia Ochoa Rosales, the doctorate degree. As a testimony and proof hereof, I present you the diploma signed by the Rector Magnificus, promoter, co-promoter, and other present members of this committee, and endorsed with the seal of the university. Congratulations.
Please be seated.
Having performed this task, may I take the opportunity to be the first to address you as a doctor and to congratulate you on your achievement. Dear Dr. Ochoa Rosales, dear Carolina, it's a great pleasure, I already mentioned this earlier, to be standing here and give you this degree. I want to congratulate you and want to involve your family and friends and colleagues in this great achievement. You came here in 2016 initially as a master's student, and then in 2018 went on towards your PhD, and that's when I got involved in your projects as well. I've got to know you as a very, very ambitious young lady, not only with respect to the PhD, but everything that involves your professional life. I've been deeply impressed, and also with the perseverance that you have shown to actually achieve your ambition. And there was, I think, the 10th proposition in your thesis. I think you really fulfilled that proposition as well, to show that you can achieve anything you want as long as you have the ambition and the will. For the rest of the Laudatia, I would like to give the word to Dr. Fortmann-Trudy to address you further. Congratulations on my behalf again.
Dear Dr. Ochoa, dear Caro, congratulations on this well-deserved PhD. And I'm also honored to be one of the first to address you as doctor and to congratulate you on this next step in your scientific career. In which I'm sure many more great achievements will follow, because in the past few years, I got to know you and admire you as a true scientist. You're curious, working very thoroughly, always learning more, reading more, and always aiming not just for numbers of papers, but always for the best possible scientific evidence. Well, you came into Rotterdam in 2016, and you already had some degrees in biochemistry and public health. Not epidemiology yet, so you embarked on a master also here at NIES in genetic epidemiology. With your already back then great CV, you were awarded a scholarship to do your PhD here. And you originally worked with Oscar, with Tauland, who joined us also today, also with colleagues actually from then vascular medicine. And you're combining not only epi studies, even lab work back at the time, with your genetic epi courses. I was quite impressed when I joined in 2017 also as your supervisor. And you worked long hours, not only because you did many projects, but also, as I noticed soon, because you set really high standards for yourself and for your work. When you didn't know a certain method, you would learn and try and read until you did. You became an expert in various analysis, working with huge databases, for which you, I think, also needed to buy a new laptops at times because it was too much. But also, when you had results ready and you were sharing it with us and we as your supervisors were satisfied, sometimes you weren't satisfied yourself yet. You would often propose more analysis, more cohorts, more replication, additional outcomes, always aiming for more and aiming for the best. And you're someone who's not satisfied with just a simple single exposure, single outcome study. And I really admire you for that. I remember even last weekend we were discussing your defense today, but you already had new ideas for one of the papers that's not published yet, that it's in your thesis. We should add more outcomes, we should add more analysis. I said, well, that's going to take you a lot of time, but it doesn't matter. If it makes the paper better, I'll do it. So, yeah, Very impressive. And we've seen that with the statin paper, for example, that started just as a, well, not simple, but an EWAS study, where you also added gene expression data, causal mediation analysis, extra cohort studies, again, always going the extra mile. And it paid off. Your hard work, your commitment, your patience, because sometimes these projects took years, right, in these large collaborations. Because you not only published great papers, you presented at international conferences, but you also won several awards. So after finishing your MSc in genetic epidemiology, for example, you won the NIAS Award for the best thesis of that academic year. Last year at the EuroPrevent conference in Lisbon, you won the Young Investigator Award, the European Society of Cardiology. And your efforts also resulted in many collaborations internationally. You participated in several consortia within CHARGE, for example, but you also led several of these international projects. So we've seen not only the Rotterdam study in your thesis, UK Biobank, but was it Cora, EPIC, Lollipop, LSPEC? I can go on and on, so many more. And you also expanded your international collaborations in Glasgow, working with Carlos, who's also here with us today, at the Institute of Cardiovascular and Medical Science, and there you work with also UK Biobank data. And of course, also there you didn't just do your single project that you were planning to do, but you also added many more, and also adding the data to your coffee project we were starting in the Rotterdam study. And for these visits, you also obtained your own grants, grants from the European Association of Diabetes, quite impressively, to do all these extra projects and tasks. And also others actually saw how good you are, because a year ago we almost lost you with a great job offer somewhere else. But we're really happy that you stay, and I think it also showed that you really wanted to not just rush your PhD, but really wanted to complete it until the end, so showing your true science. And also outside of your project, you're a true team player. I think everybody in the department and outside knows you. You help many students, supervise students, help with new data collection in the Rotterdam study, thinking of new questionnaires, organizing the seminars at the department, active member of the social activity committee, so contributing to all the cookie breaks and Christmas dinners and summer drinks we had in the team. And I think your long hours at the department also resulted in many friends from all over the world. And I hope at least many can join now online. It will be sad to see you leave back to Chile next year, but I think also it will be great to still collaborate. I think you have a great scientific future ahead of you. Like I just said already, you have so many great ambitions to set up new cohort studies and do more projects. And I think, well, and you already worked also on, for example, COVID studies last year, very committed, also publishing more papers on that actually last summer. And, well, I'm happy you'll stay with us as postdoc for a few more months, and also look forward to keep collaborating with you when you're back. Well, finally, I'd like to use the opportunity also congratulate Alejandro and your parents, who are unfortunately not here physically today, but for joining online, all your friends and family from all over the world. You can be very proud of Caro. I'd like to use the opportunity also to thank all the committee members who joined us online today. Thanks so much for joining this session and for being here now. Caro, I'm very proud of you. I'm proud to have been part of your PhD journey. Looking forward to collaborate with you. You're a true scientist. Congrats again, and enjoy the rest of the day.
Dr. Ochoa Rosales, I have also the pleasure on behalf of the doctorate board of the university to congratulate you having obtained your doctorate degree. I have a small present from the doctorate board as a memory to this very special day. It's a silver pin, it's a miniature of the top of the ceremonial staff of the Beadle. I wish you all the luck with your further scientific work, and I formally declare this meeting now closed.